Good morning, all of students. Today we meet again in online learning SMBK Menabur. I hope all of us in a good condition. This is our first meeting in the new academic year. The topic we will learn today is atomic structure. This is the first topic at grade 9. Standard competency. In our curriculum, the standard competency related with our chapter atomic structure is understanding about matter particle, atom, ion, molecules, simple structure of substance, and the connection with the properties of materials that is used in our daily life and the impact toward human health. Atomic structure. The word atom origin from Greek words atomos, which have meaning indivisible. The first concept about atom is proposed by Democritus in early 4th century BC. John Dalton's atomic model, model atom John Dalton. In the year 1804, English scientist John Dalton proposed his idea about atom. The first idea, atom is the smallest part of matter that can't be divided anymore. Jadi atom menurut Dalton itu digambarkan sebagai materi yang paling kecil yang tidak dapat dibagi-bagi lagi. The second idea, atom is depicted as small solid ball. An element has identical atoms, and the atoms of one element is different from another element. Idenya yang kedua, atom itu digambarkan sebagai bola pejal yang kecil. Suatu unsur itu memiliki atom-atom yang identik atau sejenis, dan atom dari satu unsur itu berbeda dengan unsur yang lainnya. The third idea, atoms merge create compound with integers ratio. Atom-atom bergabung membentuk senyawa dengan perbandingan berupa bilangan bulat. The fourth idea, atom from an element is eternal. So, an atom can't be created or can't be destroyed. Jadi, ide yang keempat, atom dari suatu unsur itu memiliki sifat yang kekal, sehingga atom tidak dapat diciptakan dan juga tidak dapat dimusnahkan. J.J. Thomson Atomic Model. J.J. Thomson is the first person that found electron in the year 1897. In his idea, in atoms, there are electron and proton. Proton has much greater mass than electron. Dalam model atom Thomson, di dalam atom terdapat elektron dan proton. Proton memiliki massa yang jauh lebih besar dibandingkan elektron. Mass of proton is equals with mass of neutron equals 1.67 times 10 to the power of minus 27 kilograms. Mass of electron equals 9.1 times 10 to the power of minus 31 kilograms. Thomson proposed his atomic model, that atom is depicted as positively charged ball with electrons spread on it. Thomson atomic models is called plum pudding model. Thomson mengajukan model atomnya di mana atom digambarkan sebagai bola yang bermuatan positif di mana elektron-elektron tersebar di dalamnya. Model atom Thomson ini digambarkan sebagai model atom roti kismis. Rutherford atomic model. Atomic theory of Rutherford is proposed as the following. The first atom consists of positively charged nucleus. Berikut adalah teori atom yang diajukan oleh Rutherford. Yang pertama, atom terdiri dari inti yang bermuatan positif. Second, its mass concentrated in nucleus. Massa atom terkonsentrasi di inti atom. The third, electron revolve around nucleus at a certain orbit. Elektron mengelilingi nukleus pada orbit tertentu. The fourth, atom is neutral since the number of proton is equal to the number of electron. Yang keempat, atom bersifat netral karena jumlah proton sama dengan jumlah elektron. Niels Bohr atomic model. In the year 1913, Niels Bohr fixed the failure of previous atomic theory through an experiment about spectrum of the hydrogen atom. Bohr stated his atomic model as the following. First, electron in atom revolve around the nucleus on its stationary orbit. An electron, while revolve on its stationary orbit, wouldn't emit energy. This orbit is called as atomic shell. Bohr model atomnya menyatakan beberapa hal di bawah ini. Yang pertama, elektron di dalam atom bergerak mengelilingi inti atom pada orbit stasionernya. Dan saat elektron bergerak dalam orbit stasionernya, tidak akan memancarkan energi. Orbit ini disebut sebagai kulit atom. Second, electron can exit it from its stationary orbit to another orbit with absorbing energy. While absorbing energy, electron exited from orbit which has lower level of energy to orbit which has higher level of energy, or emit an energy. While emit an energy, electron exited from orbit which has higher level of energy to orbit which has lower level of energy. Yang kedua, elektron bisa tereksitasi dari orbit stasionernya ke orbit lainnya dengan cara menyerap energi. Saat menyerap energi, elektron dapat tereksitasi atau berpindah dari orbit yang memiliki energi yang lebih rendah ke orbit yang memiliki energi yang lebih tinggi. Atau bisa memancarkan energi. Saat memancarkan energi, elektron dapat tereksitasi atau berpindah dari orbit yang memiliki tingkat energi lebih tinggi ke tingkat energi yang lebih rendah. Third, electron that move on its stationary orbit means that electron doesn't absorb or emit energy. Yang ketiga, elektron saat bergerak Pada orbit stasionernya, artinya elektron tidak akan menyerap atau memancarkan energi. Now we will see description about explanation of Bohr. Substance is composed by atoms, and atoms is composed by nucleus, and electron revolve around it in a certain orbit, and nucleus is composed by proton and neutron. So in here we can get that particle that compose an atom. First, proton, which has positive charge. Second, neutron is neutral. Third, electron has negative charge. And here we will see Bohr atomic model for hydrogen atom H. In hydrogen atom, there is just one proton in the nucleus, and electron revolve around it on its orbit. Because the atom is neutral, number of proton is equals with number of electron. After we have understand about hydrogen atom model, now we will see helium atom model and lithium atom model. First we will see helium atom model. Helium atom He in the figure, there are two protons in helium atom. The proton in the nucleus, and from the figure we can see too that there are two electrons revolve around the nucleus. Does helium atom has charge? No, of course no. Why? Helium atom above neutral. Because number of proton is equal with number of electron. Now we will see lithium atom model. From the figure we can see there are three protons in lithium atom, and as we can see too that there are three electrons revolve around the nucleus in lithium atom. Does lithium atom has charge? No. The atom lithium is neutral. Why lithium atom above neutral? Because number of proton is equal with number of electron. Nuclide and its classification. Nuclide is type of atom that can be distinguished by number of proton and its number of neutron. Example, 2He4, 8O17, 12Mg25, 16S32. Nuclide can be formulated ZXA or can be written like this, AZX. Note, X is atomic symbol, Z is atomic number. Atomic number represents number of protons in atomic nucleus. A is mass number. Mass number represents number of proton and neutron in nucleus. Based on the similarity of mass number A, atomic number Z, and number of neutrons, so nuclide can be classified into several types. First, isotope. Isotopes are atoms from the same element which have the same atomic number, but they have different mass number. Example, 12 Mg24, 12 Mg25. Both of them are the same element, Mg, magnesium. 12 Mg24 has atomic number 12. 12 Mg25 has atomic number 12. Because of that, both of them are isotopes. The second example, 7 and 14, 7 and 15. Both of them are the same element, N, nitrogen. 7 and 14 has atomic number 7. 7 and 15 has atomic number 7. Because of that, both of them are isotopes. Second, isobar. Isobar are atoms which have the same mass number from two different elements, but they have different atomic number. Example, 15p32 and 16s32. Both of them are different elements. P is phosphorus, S is sulfur. But P in here has mass number 32 and S in here has mass number 32. Because of that, both of them, P and S, are isobar. Second example, 7n14 and 6c14. Both of them are different elements, N and C, nitrogen and carbon. 7 and 14 has mass number 14 and 6c14 has mass number 14. Because of that, both of them are isobar. Third, isotones. Isotones are atoms from different elements, but they have the same number of neutrons. Example, 12 Mg24 and 11 Na23. Mg and Na are different elements, magnesium and sodium. 12 Mg24 has number of neutrons 24 minus 12, 12. 11 Na23 has number of neutrons 23 minus 11, 12. So Mg and Na has the same number of neutrons. Because of that, we can say Mg and Na are isotones. The second example, 7 and 14 and 6c13. N and C, nitrogen and carbon, are different elements. 7 and 14 has number of neutrons 14 minus 7, 7. And 6c13 has number of neutrons 13 minus 6, 7. So, because number of neutron, nitrogen and carbon are 7, we can say N and C are isotones. Fourth, isoelectron. Isoelectrons are ions which have the same number of electrons. Example, Na plus with electronic configuration 1s2, 2s2, 2p6 with 10 electrons. F negative with electronic configuration 1s2, 2s2, 2p6 with 10 electrons. This means Na plus and F negative are isoelectron. Isoelectron nuclides will be explained when we learn about electronic configuration. After we have learned about nuclide and its classification, to get better understanding, now we will see the exercise below. Look at the nuclides below. 1, 15p31, 2, 15p32, 3, 16s32. Question number 1. Determine number of proton, electron, and neutron from nucleus above. 2. From the nucleus above, determine nucleus as isotope, isotons, and isobar. Answer number 1. 15p31, number of proton equals 15. Because atom is neutral, so number of electron equals number of proton is 15. Number of neutron equals mass number minus proton number equals 31 minus 15 equals 16. 15p32, number of proton equals 15. Because the atom is neutral, so number of electron equals number of proton equals 15. Number of neutron equals mass number minus proton number equals 32 minus 15 equals 17. 16s32, number of proton equals 16. Because the atom is neutral, so number of electron equals number of proton equals 16. Number of neutron equals mass number minus proton number. 32 minus 16 equals 16. For answer number 2, isotopes are atoms from the same element which have the same atomic number, but they have different mass number. So, based the answer number 1, we can say that 15p31 and 15p32 are isotopes because 15p31 and 15p32 from the same element and has the same atomic number 15. Isotons are atoms from different elements, but they have the same number of neutrons. So, from the answer number 1, 15p31 and 16s31 are isotons because the number of protons for 15p31 and 16s32 are 16. And isobar are atoms from different elements that they have the same mass number, but they have different atomic number. 16s32 and 15p32 are isobar.